Hi, this is lesson 10.2 of accelerated geometry, and it's called two special right triangles. The first right triangle that we're going to talk about is one that has angles of 45 and 45 and 90. So this is called an isosceles right triangle. The reason it's isosceles, of course, is because if this is 45 and this is 45, the base angles of a triangle are equal, which means that the sides are also equal, and you have an isosceles right triangle. So this kind of a triangle, they say, is important in construction and in engineering. So if there are any shortcut ways that we can find out the lengths of these sides, it would be helpful in those professions. So this is what it looks like. The two legs are equal. The hypotenuse is across from the right angle. So an example would be a triangle that has legs that are 1 and 1, legs that are 2 and 2, legs that are 3 and 3. And in each of these cases, there's a question mark on the hypotenuse. So let's see if I can find that. Since it's a right triangle, I can use the Pythagorean theorem. A squared plus b squared is equal to c squared. 1 squared plus 1 squared is equal to c squared. So 1 plus 1 is equal to c squared. So 2 is equal to c squared. So if I take the square root of both sides, c is equal to the square root of 2. So this side is the square root of 2. Okay, next one. A squared plus b squared is equal to c squared. 2 squared plus 2 squared is equal to c squared. 4 plus 4 is equal to c squared. 8 is equal to c squared. So c would be the square root of 8. Now, 8 is 2 times 4, and 2 times 2 for the 4. So 8 is, I'm running out of room, I'll come over here, the square root of 2 times 2 times 2. These two 2's will come out, and inside there will be a 2. So this is 2 square root of 2. Okay, next one. A squared plus b squared equals c squared. 3 squared plus 3 squared is equal to c squared. 9 plus 9 is equal to c squared. 18 is equal to c squared. So c would be the square root of 18. 18 is 2 times 9. 2 can't go any further, so I'll circle it. 9 is 3 times 3. So this is the square root of 2 times 3 times 3. The two 3's will come out, and the 2 will stay in. So this hypotenuse is 3 square root of 2. Okay, now look at the pattern. So let me see if I can get the highlighter here. I have 1 square root of 2, 2 square root of 2, 3 square root of 2. And look at these. When the legs are 3, the hypotenuse is 3 square root of 2. When the legs are 2, the hypotenuse is 2 square root of 2. When the legs are 1, the hypotenuse is 1 square root of 2. So if I continued this, if we were having class, I'd have each row choose one of these and do each of those boxes, but we don't have a bunch of people in this room right now, just me. So let's look at what you get. So here's what we found out. If the length of a leg is 1, the hypotenuse is 1 square root of 2. When the length is 2, it's 2 square root of 2, and it's 3 is 3 square root of 2. Guess what? When the legs are each 4, the hypotenuse is 4 square root of 2. When the legs are each 5, it's 5 square root of 2. This is getting boring. When it's L square root of 2. So in an isosceles triangle, if the legs have length L, then the hypotenuse has length L square root of 2. Okay, next example. So in this case, you have another triangle. So this is our second special right triangle. This is a 30, 60, 90 degree triangle. They say it's also called a 30, 60 right triangle. I usually call it 30, 60, 90. So again, they say in construction here and engineering, it is important. So look at what they have. So this is 60 degrees, this is 60 degrees, and this is 60 degrees. But when we cut it in half, this piece up here becomes 30 degrees. That's a 30 degree angle, a 60 degree angle, and a 90 degree angle. So it says, why must the angles be 30, 60, and 90? Well, that's because I said in an equilateral triangle they're all 60, but I cut that one in half. How does BD compare to AB? And how does BD compare to BC? Remember that the sides of an equilateral triangle are equal. But if I only talk about BD, that's half of this side. So if I'm talking about BD, again, it's half of this side. Okay, so if I call this side X, this side, if this is half, if BD is half, then this BC would be 2X. See that? So this is half of this side here, which is 2X. So in any 30, 60, 90 degree triangle, how does the length of the hypotenuse compare to the length of the shorter leg? The hypotenuse is always twice as long as the shorter leg. Okay, in this investigation, we'll discover the relationship between the lengths of the shorter and longer legs in a 30, 60, 90 degree triangle. So I have to fill this in. Use what you just discovered on the previous slide to fill in the second row. The hypotenuse is always twice, so that's going to be 2. Twice 2 is 4. This is going to be 6, 8, 10, 12, 14, 20, and 2A. Okay, now the length of the longer leg. Right, this is a right triangle. And in a right triangle, A squared plus B squared is equal to C squared. Okay, what don't I know? I don't know the length of the longer leg. So one of these legs I don't know. But I do know the hypotenuse in the shorter leg. So if I'm going to do this problem, I could say that one of the legs is 1, that's squared. The other leg I don't know, I'll call it B still. And the other side is the hypotenuse, which is a 2, so I square that. So I have 1 plus B squared is equal to 4. So when I subtract 1, B squared is equal to 3. When I take the square root of both sides, B is going to be the square root of 3. So this is the square root of 3. Okay, we'll do the same thing here. The shorter leg, one of the legs, shorter leg in this case is 2, so that's 2 squared, plus the length of the longer leg I don't know. Square that. That has to equal the hypotenuse of 4 squared. So I have 4 plus B squared is equal to 16. If I subtract 4, B squared is equal to a 12. If I take the square root of both sides, B is equal to the square root of 12. 12 is 2 times 6. 6 is 2 times 3. So B is the square root of 2 times 2 times 3. The 2's come out and the 3 stays in. So this is 2 square root of 3. Okay, next one. The leg is 3, I square that, plus the other leg I don't know, has to equal the hypotenuse of 6 squared. 9 plus B squared is equal to 36. I subtract 9 from this side and 9 from that side. I have B squared is equal to 27. Take the square root of both sides. I get B is equal to the square root of 27. 27 is 3 times 9. 9 is 3 times 3. So I have B equals the square root of 3 times 3 times 3. 2 of those 3's look alike. They come out, and 3 will be left on the inside. So this is 3 square root of 3. Maybe that's enough for us to see the pattern. What do you think? When the shorter leg is 1, the hypotenuse is twice that, and the longer leg is 1 times the square root of 3. When the shorter leg is 2, the hypotenuse is twice that, and the longer leg is 2 square root of 3. So let's jump to the end here. When the shorter leg is A, the hypotenuse is 2A, and the longer leg is A square root of 3. Okay, so this is what this all says. Okay, then it says that there is a conjecture there. Now, if I go to the conjecture list, in a 30, 60, 90 degree triangle, if the shorter leg has length A, then the longer leg has length a square root of 3, and the hypotenuse has length 2a, is conjecture number 91. And that is the end of that lesson. Thank you.